Reactive Surfaces is developing an arsenal of decontamination products and approaches to address the various scenarios in which exposure to chemical weapons may occur. Reactive Surfaces believes that one of the best test beds for its suite of decon products and techniques are the Chemical Materials Agency facilities currently being used to decontaminate chemical weapons stockpiles. Reactive Surfaces offers a multifaceted approach to chemical agent decontamination for chemical demilitarization facilities. Existing decontamination technology suffers from several drawbacks. One drawback is that the existing decon solutions themselves are highly toxic and caustic, posing risks to personnel and machinery. In addition, caustic decon solutions add unnecessary chemical contaminants to the waste streams. Existing technology does not address important aspects of the overall chemical weapon decontamination goal, namely plant closure and depot remediation. Transport of primary and secondary waste from CMA facilities is not an option. Thus, secondary waste buildup at CMA facilities has already become a large concern, as these materials cannot be readily disposed of and are presently being stockpiled for lack of effective decontamination techniques. An integrated system using components of the Reactive Surfaces product line will address many of the current deficiencies, substantially extending the life of the decontamination plants and equipment, increasing worker safety, decreasing downtime on campaign changeover, reducing secondary waste buildup, and ultimately allowing plant closure. Certain Reactive Surfaces products are designed to protect surfaces and workers by application in advance of exposure. Surety laboratory testing at Dugway Proving Grounds has demonstrated that Reactive Surfaces OPDtox additives can be formulated in paints and coatings to decontaminate neurotoxins on coated surfaces immediately upon contact. Studies at Texas A&M University have shown that concrete surfaces coated with Reactive Surfaces paints prevent contamination of the underlying concrete, or can be used to decontaminate previously contaminated concrete surfaces. Reactive Surfaces additives have been shown to work even in the presence of large concentrations of organics, such as methanol. Studies have been conducted at Southwest Research Institute on OPDtox additives used in slurries on surfaces routinely encountered in CMA facilities. Reactive Surfaces OPDtox decon solution compared very favorably with the caustic decon solutions MDF-200 and Decon Green. Viton, butyl rubber, as well as stainless steel can be effectively decontaminated by Reactive Surfaces additives without degrading the integrity of the surface, since the pH of the Reactive Surfaces solutions is approximately neutral. This is in marked contrast to existing procedures using caustic decon solutions. Standard firefighting equipment can be easily modified to provide a protective mist for first responders entering a hot, contaminated space in which not only liquids but vapors present threats. The mist-applied additives continue decontaminating after settling on contaminated surfaces. Reactive Surfaces is having discussions with a major governmental supplier of firefighting fireproofing equipment to co-develop the necessary modifications. Working with the internationally recognized Paint and Coatings Group of the University of Southern Mississippi, Reactive Surfaces is placing OPDtox additives into clear acrylic latex polymer coatings. These textile coatings were originally developed for the permanent pressing of U.S. Marine Corps battle fatigues. With the Reactive Surfaces additives, such textile coatings should create barriers to skin contamination by low-dose exposures to neurotoxins. These coatings will be useful as secondary barriers on clothing worn under a hazmat suit or as an after-exposure emergency textile coating. Working closely with a well-known refinery equipment manufacturer, Reactive Surfaces has developed a commercial-grade decontamination column relying upon OPDtox painted surfaces to rapidly decontaminate solutions. These units can be used in combination with a wet vacuum for mobile decon, used in a smaller configuration as a fixed decon unit in sumps or other reservoirs, or scaled up to handle very large liquid decon operations capable of supplementing or replacing incinerators and chemical hydrolysis oxidation units. Studies conducted in collaboration with Pacific Northwest Laboratories indicate that Reactive Surfaces OPDtox additives can be deployed using fog-generating equipment to reach surfaces not otherwise reachable using mists or slurries. Interiors of equipment as well as HVAC ducting and air handlers can be treated with the Reactive Surfaces enzymatic decon additives using fogging. While at present Reactive Surfaces decon solutions, painted surfaces, and decon columns are designed to treat more dilute concentrations of chemical agents, Reactive Surfaces is applying the same technology to systems capable of decontaminating concentrated agents, with the goal of supplementing or actually replacing incineration techniques or caustic chemical decontamination methods. Manufacturing of Reactive Surfaces chemical decontamination additive is based upon proven fermentation and processing techniques. Production of OPDtox has been scaled up from the bench level to a commercially feasible level, resulting in a relatively inexpensive stable powder that is easily stored, transported, formulated or mixed, and deployed. In the late 1990s, Japanese terrorists released sarin in Tokyo subways. Although human casualties might not have been totally avoidable, had Reactive Surfaces' arsenal of decontamination products been available, such casualties would have been greatly reduced. Surfaces, including air handler ducts prophylactically treated with paints and coatings containing Reactive Surfaces decon additives, would have immediately begun decontaminating surface-deposited neurotoxins. Sniffers would have activated pH-neutral water-based firefighting fireproofing sprays and mists to cleanse air and accelerate surface decontamination, especially on surfaces not easily prophylactically treated. First responders entering the subway stations and cars would have been armed with protective mist and fog-generating equipment charged with the water-based benign OPDtox additives. And the liquid waste generated from the cleanup would have been further decontaminated by collecting, such as with a wet vacuum and passing through Reactive Surfaces decon columns. The first responders would have been wearing protective garments impregnated with OPDtox additives, and the clothing of casualties and others on the scene would have been similarly protected. Testing at facilities like the Chemical Materials Agency demilitarization plants and the Nevada Test Site National Center for Counterterrorism will serve as an excellent analog to test Reactive Surfaces' suite of decontamination products.